So I did electrical engineering at the University of Birmingham. I studied power electronics. I got very passionate about using thyristors. I came from a world of power electronics where we used lots of thyristors before we got to using transistors. If you think about the impact of power electronics in the world, you've got power supplies for computers, you've got lighting circuits for LED lighting systems, you've then got industrial drive systems for energy efficiency of water pumping, air conditioning units, and then you've got these really sophisticated variable speed drives for marine propulsion. We use them in aerospace for starting gas turbines and also for transport. And I mean, if you look at the automotive industry, there are millions of vehicles being built today that are absolutely leaden full of power electronics. If you think about a ship, it is an islanded system. You're going to have that degree of high-level integration. When we integrate the high-energy weapons in naval systems, for instance, this is where you get the real sort of engine as a weapon that comes in place, you know, where the engine is going to react, you know, or preempt what's going to happen with these high-energy load systems. Some of the big challenges for the industry is around thermal integration, the federation of different systems, bringing them together to get your power density, to get your environmental requirements right, you know, and to get your availability of your equipment up as well. We do a lot of hardware in the loop for engine controls. You have to do that for certification purposes. You have to do that for you know, sort of developing your next generation of controllers, as it were. In the marine world, we do a lot of work with real-time simulators. We've got our own simulation systems that we use for training operators that we can actually use to simulate dynamic positioning systems, as well as winch and deck machinery systems, seismic streamers. Yeah, it's becoming really important because what you're trying to do is trying to drive down development costs. You're trying to drive down rework, as it were. And you're trying to get to your developed product much quicker. Yeah, hardware in the loop is a very important thing for Rolls Royce and for companies like ourselves that sort of work in this, you know, sort of very fast-moving types of industries where we have to get the product very quickly to get to value.